Just, sir, start.
Good morning, all the dignitaries, eminent participants, ladies and gentlemen. This is Professor Sunil Khachne, coordinator of FDP at RGIT Mumbai. Welcome you all on day 2, the third session of 1 week online FDP on engineering education and the industry, a post-COVID-19 perspective, jointly organized by Indian Institute of Industrial Electronics and Manjra Charitable Trust, Rajiv Gandhi Institute of Technology, Mumbai. As you all know that we have more than 1300 participants registered from all over India and a few from abroad. Our entire team feel proud on this occasion, as this is our first experience to organize an online FTP. Being too many participants, my humble request to all the participants to join in time. Over to Priyanka. Please run the video. Sound. No sound. Thank you, Priyanka. I feel privileged to introduce our today's guest and keynote speaker, Honorable Dr. S.S. Mantha. Dr. S.S. Mantha, former chairman of the national regulator, All India Council for Technical Education, New Delhi, implemented several e-governance initiatives and facilitating regulations. Earlier, a professor of robotics, control theory, and artificial intelligence at VJTI Mumbai. He now occupies the Emirates chair. He has more than 280 publications in national and international journals and conferences, besides authoring 3 books. Presently, he is Chancellor, KL University, and Adjunct Professor at the National Institute for Advanced Studies, NIAS, Bangalore. He is also Chairman of Technical Committee, National Cyber Safety and Security Standards, NCSSS, and IT expert for the government of Maharashtra. Today, he is going to speak on the topic education and the future challenges. Without wasting much of your time, I, on behalf of our management, our institute, and my own behalf, invite Honorable Dr. S.S. Mantha, sir, to deliver his keynote address. Dr. Mantha, sir. Over to you, sir.
Yeah, thank you all, and good morning to you all, the organizers and the participants, and all those who are watching this webinar. These are very challenging times, and everything has been disrupted like never before. And we really need to understand how the education space will evolve in the next 1 or 2 years. We've been talking about online education, distance education before that for a long time now. And there have been instances when online education has been effectively used in our institutions. Now, what this pandemic has done is it has compressed the development cycle for online education, and probably in future, what we will see is the coalescence, the mixing of formal education and probably the online education, the face-to-face and the online education. Now, what that really means is we'll probably be getting into what we term as blended learning. Now, blended learning has uh, its own ways of uh, being looked at, and there are obvious advantages. There are also problem areas, and so on. Now, in this changing space, there is institutions on one side, and there is the industry on the other side. Now, the industry also has been evolving over a period of time, and industry also has been evolving over a period of time, and a lot of automation has set in into all kinds of uh, industry requirements. Now, having said that, the industry has been transforming with initiatives which are essentially based in automation and is moving towards Industry 4.0, as we wish to call in these days of extreme automation. Now, obviously, in order to run Industry 4.0, you will also need to understand the skills that are required for Industry 4.0. And the skills that you require probably will be termed as Labor 4.0. So therefore, on one side, you have Industry 4.0, which needs a different set of skills. And in order to get those skills, you will need Labor 4.0 who has those skills. And those kind of skills must come from the universities, from the institutions, from the skill centers, and so on. So today we are really looking at some kind of synergy between what we want to do in the universities and how the skills that are given within the industry, how they will probably translate the skills that you give in the university, how they will translate into the skills that are required by the industry. Now, in this process, obviously, there is an education chain, supply chain, and we need to understand those requirements of education. Now, there is a universal truth when we talk about education, and what it means is all humans are dead except those who have knowledge, and all those who have knowledge are asleep except those who do good deeds. So you should have knowledge, you should also do good deeds. And those who do good deeds are deceived, except those who are sincere, which means you should have knowledge, you should do good deeds, and you also have to be sincere. But unfortunately, those who are sincere are always in a state of worry. Now, this is the universal truth, and we need to break this jinx and get into the formal learning of education, formal process of teaching, learning in an institution. Now, if we teach today's students as we taught yesterday, we rob them of tomorrow. Now, what it really means is we need to move with the times. and see and make an estimate of what the students need in terms of skills. And that is what the university must move to, or that is what the institutions must move to in terms of education that is required by the industry. Because ultimately, all the students who pass out, to graduate, they need a meaningful employment. And without the skills that are required for a meaningful employment, they would not be employable. Now, when we look at the evolution of education, it has closely followed the industry. The industry 1.0, the first industrial revolution, where things like printing press was a great innovation. It actually brought the entire culture into the homes because of the printing books, because of the printing that was possible, which was an outcome of the first industrial revolution. And the education followed what skills were required through the industrial revolution 1.0. Then you had industry progressing into 2.0, 3.0, and today we are currently at 4.0. And therefore, education also has progressed through those development cycles. And whereas education 1.0 had lectures and memorization, education 2.0 was more internet-enabled learning. People used to go to the internet and find out whatever material they find on the internet. Believe me, on the internet, most of the material is not authenticated. So therefore, it was a problem area. And education 3.0 is a knowledge producing education. And we were actually producing knowledge workers. And education 4.0 must follow the requirements of industry 4.0, which means innovation producing education. There's a lot of talk of innovation in almost every sphere that we have today. And innovation means not creating a new product, a new process, even a simple change in the process, the existing process, or change in the existing design of a product, which can improve the process or improve the product, is also innovation. So we are today talking of improving the processes and improving the products, bringing in some value addition to the existing products, and that's what innovation really means. Now, if you look at this slide, we are moving from e-learning to digital learning in just one generation. In 1998 to 2002 period, we had e-learning and blended learning. We are still talking about blended learning today, but the technology has progressed from those times. Around 2005, we had talent management, and around 2010, it was more of continuous learning, lifelong learning, and so on, with the tools that were available. And around 2017, we had digital learning, and today we are into intelligent learning. Not everything need to be known by a person, but there must be intelligent learning in the process. So most of the tools that are developed today, the learning management systems and so on, are trained towards intelligent learning. There are several commercial learning management systems available in the market, and we will look at some of them later. Now, let's see how the world is moving. In 2020, we have 1.3 million logins of Facebook every single minute. 19 million texts are sent, and 4.7 million videos are viewed over YouTube in almost a minute. 4 lakh applications are downloaded. 59 million messages are sent. 1,400 TikTok downloads are done, and so on. Almost 8 lakh hours of Netflix is watched, so on. This is Internet 2020, minute, every single minute. Now, this shows how fast the world is moving and how fast people expect that the environment around them also change. So what are we up to in year 2020? Now we have a future of education, and here preparation for 4.0 is extremely important, and an era of alignment between man and machine is required. Industry 4.0, there are several automated machine tools, machines, and so on. There are flexible manufacturing systems where several robots will be operating in an automated environment. And here we have a scene where machines will speak to people, people will speak to machines, and even machines will talk to machines, and that is 4.0. Now, all this means that we need to align industry requirements with education. There, for example, the industry requires flexible production lines, online quality control, workers monitoring automation, custom products, smart products, system engineering, and lifelong learning. Whereas the education must align to the requirements of industry, and which means that tailor-made learning paths are required. In future, students would probably make their own assembly of courses and would seek degrees on that basis. And maybe they will not be interested in a simple BTech in electrical or BTech in mechanical and so on. So it's something like designer degrees and made to order degrees is the future. And we really need to look at the future universities and how they will evolve, future education, how that will evolve, what is virtual education, and so on. So there are tailor-made learning paths, there are formative assessments. The assessments have to undergo a massive change. Teachers will have to become mentors. Today, teachers teach in the class. Tomorrow, teachers will have to become guides. They will have to become mentors. And that transition is not very easy or simple. Divergence and pluralism and taking everybody together at the same time creating a massive divergence into the thought process is also something that is required and must happen through education. Finally, education must be the goal, and continuous teacher training is also required in order that all this happens. So the next 20 years, what does that hold for us? And that is Industry 4.0. So let's see what is Industry 4.0. And you have fourth industrial revolution in manufacturing and industry. Most of the developments have taken place because of a massive development within the electronics and the communication sector. And that's what has been driving Industry 4.0. Now, the current industrial transformation with data exchanges, cloud, cyber-physical system is something extremely important in terms of Industry 4.0, big data, artificial intelligence, IoT, and many more. And there are tools which are available for addressing each one of these problems. Now we have, let's say, there are several definitions, commercial definitions available. These are all consulting agencies, KPMG, Davies, SME Corporation, Malaysia, and so on. Let's see what SME says about companies orienting themselves to the customers through e-commerce, digital marketing, social media, and the customer experience. Now, these are the tenets on which the entire business world will move, and therefore industry will have to align to that. And going backwards, labor will have to align that, and still going backwards, you need education to align to all that. Now, if you look from 1760 to 1840, you had a mechanical production, railways and steam engines. This was Industrial Revolution 1.0. 1870 to 1940, you had mass production, electricity, assembly lines. 60 to 2010, you had computers, semiconductors, mainframe computing, personal devices, internet, and so on. Now we are into Industry 4.0, which actually asks machines to talk to machines, and so on. And a lot of intelligence is built into the system, which allows you to take several decisions on the fly. Now, there is at the end of industry, at the end of 18th century, we had Industrial Revolution 1. And if you look at the Industrial Revolution of 4.0, you will see the level of complexity has risen multifold. The complexity was very, very low at the low end in Industry 1.0, and the systems have become extremely complex, and the ease of working has become extremely easy, extremely simple. Now, there is an interrelationship between the industrial revolutions and the societies that they nurtured. And in terms of future, maybe by 2025, there are several tipping points that exist. Our world is connected. It's a connected world. It's a networked world. It's a digital world. And there are several communicating devices which keep talking to each other. For example, when you go on the street, there are several cameras which are spying on the road, and which are looking at the traffic that happens. There are several security systems. There are several mobiles. Every one of us has a mobile, and they are all communicating devices which keep talking to each other, and so on. So there are 1 trillion sensors connected to the internet. These are all basically sensors. Every mobile has a camera, and even currently there are so many people connected on this network. So all these devices, they are connected to each other, and so on. When you switch on your machine, you're connected on the web, and it just means that every single machine on the web can actually talk to you, can actually see you, provided certain fundamentals are ensured. The first robotic pharmacist in the US by 2025, the first 3D printed car in production, the first transplant of a 3D printed liver. 3D printing is extremely important. And driverless cars equaling 10% of all cars on US roads, and so on. Now, these are the tipping points. Some of them are actually have already happened, though they are estimated to be in 2025. And that's how fast the technology is moving. Now, like I said, cyber-physical systems is extremely important. Robots as colleagues instead of work tools. So machines talk to machines talk to people talk to machines. And that's how ergonomic relief for the older staff members, highly incriminating and physical tough jobs, reducing new tasks. Now, all these are possible through robot programming and robots. And they're all cyber-physical systems. So what exactly is cyber-physical system? At the core, you have information. And around that, you have cyber-physical systems. For example, several sensors which are interconnected together. You have, like I said, you have cameras, you have mobiles, you have PCs, you have any communicating device that can talk to each other and goes on the World Wide Web. So you have computation, you have control and communication, and on the periphery of cyber-physical systems, and the whole thing together creates the interconnected world that we have today. So a cyber-physical system is a system of collaborating computational elements controlling physical entities. There are several physical entities in this world, and every one of them is controlled, coordinated, and integrated by computing and communication software. And that is the cyber-physical system that we are talking about. Now, as a part of Industry 4.0 and a digitized economy, you have, like I said, several communicating devices, which are Internet of Things. And the mid layer is the digitized services, Industry 4.0. And there's a blank left here. That's for how Industry 4.0 will evolve in future. At the current point of time, you probably won't know. So that's left blank. You have smart products, you have smart factory, and this mid layer actually constitutes labor 4.0. At the bottom, you have product innovation, process innovation, autonomous agents, which are basically driven by AI and digital networking. So between Internet of Things and processes, digital networking, and so on, you have labor 4.0. And the skills that are required by labor 4.0 are the skills that must be ensured within the universities and within the institutions. Now, when you come to building blocks of Industry 4.0, you have autonomous robots, simulation, horizontal, vertical system integration, you have IoT, you have cybersecurity, additive manufacturing, augmented reality, and big data analytics. Almost every single technology is encompassed in order to realize Industry 4.0. Now, it impacts every aspect of value chain, and by value chain, I mean anything that adds value to a business process. So you, from asset management to manufacturing, operations management, to sensors, actuators, human resource, you name it, and that forms a part of the value chain that is affected by the Industry 4.0. Now, we have an entire value chain that is digitized and integrated, and therefore there is a seamless integration between digital world and the real world. The real world has product design, production planning, all the typical production processes. And on the real world, you have simulation, you have product life cycle management, you have manufacturing execution systems, total integrated automation, life cycles, data management, and so on. Now here, everything will happen on the cloud, and therefore suppliers, logistics, digital production, physical production, customized productions, virtual productions, everything will happen on the industry, will happen on the cloud in an Industry 4.0 environment. Now, this is a kind of simulation where I have tried to show you that machines keep talking to machines in a typical 4.0 industry environment. For example, a machine, probably the magazine is empty, and refill the magazine, turn me on, I can work this Sunday, magazine is empty, things like that. You know, your BBQ weekend is cancelled. I got to be at the goods issue in 2 hours. These are not people talking to people. These are machines talking to machines. And this is a German factory where in a future concept, you will have 50% robots and 50% employees. And this is where we are going. In fact, there's the Mercedes-Benz factory is completely automated, and robots function in a flexible manufacturing mode, and they produce one Mercedes every 10 minutes. That's the kind of things which we are seeing for the future. Now, this is an interesting slide I have, which maps 2018 to 2027. And if you look at the operations, in 2018, they spoke about, and this incidentally, these 21 tipping points were predicted in 2015. And storage for all, robots, services, Internet of Things, implantable technologies, ubiquitous computing, 3D printing, driverless cars, Bitcoin and blockchain was predicted to happen in 2027. Now, if you see all of this that is predicted for 2027 is actually happening in 2020. So this is the way the development has happened, and therefore we need to create education and systems to match the requirements of the industry. There are basic 6 design principles. One is interoperability, virtualization, decentralization, real-time capability, service orientation, and modularity, and flexibility within smart factories, changing requirements, individual modules, cyber-physical systems, Internet of Services. All these become extremely important in terms of the design principles on which an Industry 4.0 is dependent on. So within decentralization, the ability of cyber-physical systems within smart factories to make decisions on their own rather than top-driven, it's a distributed environment that will function in Industry 4.0. Now, this is also a very interesting slide. In 2006, we never had an iPhone, we never had an iPad, a Kindle, which has almost 5 million books, e-books, 4G, Uber, Airbnb, Android, Oculus, which is again AR, VR devices, Instagram, WhatsApp, by which we swear today, these were not available in 2006. And we are just 10, 14, 15 years ahead, and the technology has been moving at phenomenal pace. We had a telephone that took 75 years to develop. Web took 7 years to develop. Facebook just 4 years. Instagram just 2 years. And Pokemon Go took just about 1 month to develop. Now that's the evolution, that pace at which things have happened. Now the smart products that we find today, there is a Philips lighting which controls, lighting hue within the light tubes through a smartphone and so on. We also have Medtronic implanted digital blood glucose meters, which monitors the sugar level within the human bodies. There's a Ralph Lauren, smart shirt, which is similar to a smart watch that we wear, which monitors the parameters of the human body. A Babolat, which actually, can simulate and predict the movement of a ball when it is hit, and so on. Now, that is the kind of smart products that we are talking about, and therefore, the back-end support, which is obviously given by the education system, must also support that. Now, here, obviously, this affects everything. It affects growth, aging, productivity, employment, nature of work, and so on. Now, in the new world, there are certain skills that are required, and that's where the education part comes in. In 2020, you need complex problem solving, you need critical thinking, creativity, people management, coordinating with others, emotional intelligence. It's not enough to have intelligence in an environment where you have machines, you have people interacting with people, and so on. You need emotional intelligence that will actually connect people together, understand people's requirements, and so on. And taking decisions based on a collective understanding of people around you, judgment and decision making, service orientation, negotiation, cognitive flexibility. Increasingly in a future environment, you need to do multitasking. You need to be capable of doing different things at different times, and so on. So cognitive flexibility is extremely important. These are the skills that must come from an educational institution. And we need to use tools that will allow people to mature into this, in addition to the domain skills that will be anyway required to be effective. Labor 4.0 asks for emotional intelligence that like I told you, the self-awareness, self-management, social awareness. What is society for me? What is me to the society? How do I manage myself? How do I manage conflicts with others, conflicts within oneself? How do I become a coach and a mentor at the same time? How do I influence people and teamwork? These are all basics of emotional intelligence, and that is extremely important. Cognitive flexibility is another that I talked about, able to do multiple things with equal ease is something that is required. There are several challenges of the workforce, for the workforce, rapid change of necessary qualifications, something that I enter an industry today, like for example, I have a BE mechanical or whatever, and I enter an industry, and within 2 years, I find that the skills that I have acquired within the university or within 6 months they become outdated, and I'm forced to learn new skills and so on. Ergonomical improvement through use of robots, creation of new jobs. The classic pyramid-like structure of an employment market is collapsing. For example, you have low-skilled, multiple jobs available at the base, and as you go to the top, your skill levels go higher and the numbers become smaller. That's a classic model that is being disrupted today because of automation, artificial intelligence, and so on. The bottom is compressing, and no longer there are multiple jobs of low-end skills at the base. What you have today are, higher level requirement requiring jobs at the base, and that number is also compressing, and therefore the base is shrinking in a new world. So therefore, more skills are required, higher order skills are required even at the base of the pyramid. So this is a challenge of the workforce. Now we have seen what the industry requirements are. Now we'll see how the teaching maps into the new world that we are talking about. So what is this future loading, and can our classrooms be as dynamic as the world around us? So this will have a clear impact on higher education. How will the lecturers teach? How will the students learn? What will they teach? What will they learn? What are the roles of the students? What are the roles, new roles for the teachers? They all become extremely important. Now, if you looked at the educational requirements vis-a-vis the requirements to be employed in and meaningfully employed in an industry, you needed 20% professionals in the 19th and 20th century. You needed 30% merchants and office workers, and about 50% of physical laborers. Not anymore so, because the entire paradigm has been disrupted. Like I've been saying, the base of the pyramid has been shrinking. So therefore, you need a very small number of unqualified temporary and seasonal workers. In an 8-part scale, you will have just one part of that, and the remaining 7 parts are hardworking, self-educated workers with initiative to do their own work at their own time, which calls for development, achievement, and with higher taxonomic and cognitive levels of competencies. Now, this is where the university teaching, learning, all that makes a difference. Now, this is the fusion of future intelligence versus the information society. And this has to be cultivated in order to be meaningfully employed within an industry. Now, this will need cognitive skills, it needs emotional skills, physical skills, and social skills. And on the periphery, you will need contextual intelligence, you need emotional intelligence, physical intelligence, and you need social intelligence. They all together make a person be acceptable within the new environment where a lot of machines will have to interact with people, and people will have to interact with machines. And therefore, your creativity, your communication skills, your critical thinking ability, the collaboration that you can enter with your peers, with your people within the factories, outside the factories, the character that you take with you, the citizenship and the copyrights that you have, these are all important in a future world. So therefore, most of the, and we are also, like I said, digitally connected network. So, and we all keep conversing on the mobile. So mobile learning oriented systems will become one of the future requirements. And smart learning, what to learn and when to learn and how much to learn, that's smart learning. Flipped learning, what you do in the classroom and what you learn outside the classroom. Collaborative learning with your peers, with your people, and so on. Hybrid learning, partly learning within the classroom, partly learning outside the classroom. Social learning, the vis-a-vis the relationships with the society. Emotional learning, how do you connect with people? How do you connect with systems? Measuring learning, how do you measure what I learn? what you learn, and the phenomena of learning itself. So these are the things that we really will need. And therefore, this is something where these are actually the learning ecosystem in response to the fourth industrial revolution. It actually takes everything together and puts them into compartments, and each one is actually supported by a software tool today. And therefore, the learning ecosystem is something that will evolve in times to come. Changes, there are several changing trends that we have seen. Like I said, much of the learning can happen outside the classroom, and some learning will happen inside the classroom. And therefore, we are actually moving towards blended or hybrid learning. So therefore, the digital content becomes extremely important. And there are certain characteristics of digital content. It must be interactive, must be characteristic, it must have some very specific characteristics. It must be mobile based, must be global, realistic in terms of augmented reality, virtual reality, and must be emotional. It must be able to connect. It's not something, some one-way traffic that happens. For example, when you're watching a TV, if you do not like a certain program, certain software, you tend to change the channel. That must not happen while you're learning in an asynchronous mode. And therefore, there must be some emotional connect that happens even when I do not uh, engage a person face to face, but only have him on the other side in an online virtual world. Now, in this process, there are several open online courses available, and there are several learning platforms available, like Moodle and so on. And the open online courses are available, like XMOOC, which is the most common type of MOOC and organized around a central professor and a core curriculum. You have CMOOC or Connectivity MOOC that resembles graduate seminar courses for student discussions, and DevoCC is a distributed online collaborative course. And DevoOC is a big open online course, which is similar to MOOCs, but limited to smaller number of students, typically 50. So what we are trying to do is bring in the classroom experience into the virtual world by limiting the number of students and making the learning experience much more profitable. You have XMOOC, synchronous massive online courses. You have small private online courses, which are similar to books. And you also have nano open online courses. In fact, if you give a 45 lecture in a virtual world in an online mode, it probably will not sink in from a student's perspective. So what you really need to do is break the entire content of, let's say, 3 or 4 credits, which typically takes about 45 to 60 hours. You break that into 5-minute modules, 10-minute modules, or 5-minute modules of 9 modules, and that becomes a 45-hour, or maybe multiples of that. You you have, let's say, 10-minute modules, and for a 50-minute course, you have 10 modules or 5 modules or 10 modules, things like that. You break it into as many smaller modules as you want, and then create a concept around that, create a teaching, learning, coursework around that. And then at the end of those 5 minutes or 10 minutes of an online session, you have a continuous assessment to find out how much of learning has been, uh, you know, uh, achieved, and so on. So therefore, these multiple uh, units of 5-minute duration or 10-minute duration, which goes into creating a 45-hour coursework or 50-hour coursework. Now that is built into the most of the professional online content management platforms, and that is how you manage to engage the student to the coursework and make learning much more effective. There are several MOOC platforms. There is edX courses. They are very interesting, can be quite challenging. Coursera offers more than 4,000 courses, and most of the courses are created by the best of the faculty from best of the universities. You have Khan Academy, you have Udemy, Canvas, you have FutureLearn, Udacity, Open Education, Europa, and so on. Now, you also have typical learning management systems like BrainShack. You have SAP content. You have uh, several other learning management systems the world over. There are several teaching learning methodologies, obviously, which people will have to get accustomed to. Here, I'll just go through the substitution augmentation process, where a teacher creates models, technology, integrated lessons for students. Now, that is typically what is happening. You apply, you understand, and you remember. In a modification redefinition process, you have technology allows for significant task redesign, and it also allows for new tasks previously inconceivable, which means you create, you evaluate, and you analyze. So you break down SAMR, substitution, augmentation, modification, and redefinition. And therefore, this is how your teaching process will evolve now in terms of what is required by Industry 4.0. Therefore, entire engagement of teaching learning must happen like an adventure. It must engage people. There must be autonomy in the way this is done. There must be specific goals set, specific purposes made. There must be a feedback in order to understand what is happening in this process. There also must be a challenge, and there must be an achievement. There must be rewards for people who excel, for people who do not so much excel. There must be some way of bringing them back into the system. And there also must be masters created in this. And above all, the gamification and the teaching and the learning process must actually become fun. And that is how involvement happens. So therefore, you have three systems: pedagogy, which focuses on co-learning or co-creating, and you also have hudagogy, which allows a student to create directed learning, or you find out what is required upfront and then go and search and on the content that is required for that purpose. You also have cybergogy, and therefore this is how the shift in learning environments is happening. Cybergogy obviously encourages learner engagement in an online environment, and hudagogy encourages self-directed learning. These are the systems which, since I have done that, I'll skip a few slides here. The new pedagogy, the new andragogy, hudagogy will need to be understood specifically in order to move towards blended learning and trying to get the best out of online learning methodologies. So some of the slides I'm taking off here, and we'll come to traditional classroom and a flipped classroom. In a traditional classroom, we all know what happens. The teaching happens within the classroom. Now, in a flipped classroom, instructor records and shares lectures outside the class, and so on. So there is flipping the bit of the activities that happen within the classroom and outside. And it's a great learning methodology that can be used. It enhances individualization, personalization. In future, personalization of learning is extremely important, which means every student has specific requirements of learning, and the entire institutional learning, the university learning, must move towards giving what the student requires and not what the university thinks should be given to a student, or what the faculty thinks should be given to a student. Then we have a new way of thinking. Obviously, we have competencies of the 21st century that are required. You have analytical skills, you have critical thinking, problem solving, decision making, R&D on one side. And on this matrix on the other side, I have interpersonal skills. I have ability of realizing, information processing, ability of changing, learning. And this matrix will actually tell you how to go about the teaching learning in an online environment. For example, analytical skills, or for example, problem solving and information processing will actually take you to media literacy and so on. So these are the new requirements. And this is the Edgar Dale cone of experience, which most of you must be knowing. 10% of what you read, you remember. 20% of what you hear, you remember. 30% of what you see, you remember. 50% of what you see and hear. 70% of what you say and write, and 90% of what you do. So which brings us back to experiential learning and the hybrid learning part of it. So therefore, online learning will get you the best of the content from best of the people, and the experiential part must go back to the institution, to the labs, and so on. There is a virtual lab experiment that is happening. The IITs are pioneering that effort, and some of the simulation can be looked at through virtual labs, but the hands-on skills can be got by actually doing. And therefore, the blended learning becomes an important part, at least for applied sciences. So cognitive flexibility is something that's extremely important in an Industry 4.0 perspective. And what it really means is critical thinking is reflective, and reasonable thinking is focused on deciding what to believe or do. And it also refers to the use of cognitive skills, and critical thinking is the ability and willingness to test the validity of propositions. Now, having said that, cognitive skills will require, cognitive capacities. Now, what that means is sustained attention. When you are on an asynchronous mode, how do I, ensure sustained attention? I do not know who is on the other side. I have an online lecture going. How do I engage the other guy with a sustained attention? How do I do response inhibition? For example, sustained attention is the basic ability to look at, listen to, and think about classroom tasks over a period of time. And in an online environment, it becomes even more difficult. Response inhibition, spread of information processing, cognitive flexibility and control, multiple simultaneous attention is the ability to multitask with success. It's the ability to move attention and effort back and forth between two or more activities when engaged in them at the same time. Now, these are the kind of skills that are required in future. Working memory, category formation, pattern recognition. How does your brain do that job? And how do you translate that as a skill into people? These are the important aspects of future learning. So what is the future? We look at pedagogy, the andragogy, the cybergogy, the utagogy, online courses, blended learning, virtual universities, and so on. Now, before going a little further, we will look at a little bit of what blended learning is. At least a part of that is through online, part of that is offline. So with some element of student control over time, place, path, or pace is blended learning. So a part of it is done online, part of it is done within the college, and the modalities along each student's learning path within a course or subject are connected to provide an integrated learning experience. There are several models of blended learning. It all depends on what is your class size, what is your class, the level of the students participating in this, and so on. So you have a rotation model, you have a flex model, you have a la carte model, and enriched virtual model. The rotation model has still submodels: station rotation, lab rotation, flipped classroom, and individual rotation. So in future, when we get on to complete online education blended with certain hands-on skills within the colleges, we'll really need to work out what kind of blended learning model will be the best in a given situation. So we'll not go into too much of details of this, but we need to understand that there are several models which are, and each model has its own uh, advantages in a given situation, and we really need to find out what suits our case better. So therefore, what we really need to do is we should have an easy access through various devices. Obviously, in a connected world, we may use several devices for learning. There must be access through various devices. There must be big data management for learning analytics. There is a lot of data that is produced. There must be some data management of this data and intelligent patterns emerging out of that, which will help the teaching learning process, blended online, offline learning, various digital content sharing and collaboration, training for teacher, competency development, service quality. Quality assurance becomes extremely important. The accreditation process, which some of us must be aware of, is not the probably the future. What is really required is quality assurance, which means you guarantee the program outcomes, the course outcomes that you write in your documents for a accreditation process. Now, how do you assure them? In conversely, what it means is, in a true quality assurance process, the in a true quality assurance process, what happens is the uh, the customer reserves the right to sue the organization if the outcomes are not delivered. Now, in an accreditation process, nothing like that happens. You only get either a 3-year accreditation or a 5-year process, or you do not get accredited. There is no real connect that happens between the customer and the service provider. In a quality assurance methodology, it's extremely important that quality assurance is understood in its spirit. So the universities of future obviously will have to undergo organizational structural changes. Accreditation processes have to change. Like I said, quality assurance comes in, change of teaching methodologies, change of learning styles, and so on. Business models have to evolve. Cooperative structures have to come in. Examinations will have a very new role. The fixed degree programs will be there, but it will evolve into student-defined degree programs. And there will be acceleration cycles for students and so on. If someone is able to learn much faster, those must be available, those methodologies must be available to him. If someone can complete his BTech program, for example, in 3 years' time, that facilitation must be made. Flipped classrooms, massive versus personalized learning. That's a very important factor. Every student becomes an important cog rather than 60 students in a classroom and we do not know how much each learns and so on. So these are the concepts that will happen in a university of the future, and probably this will further evolve into what is truly a virtual university. So let me take you to the big picture of education technology pedagogy. Now, this is something that a summation of all that I have spoken about in terms of pedagogies, evolving pedagogies. And I hope you can see this pedagogy wheel. And I mean, this is just a consolidation of all the development that has been happening in terms of teaching learning processes. Now, having said that, we move to quickly to what the future holds for us. Typically, we must also make the transition into fitting the bill for the Industry 4.0, and therefore we need to worry about code labs, pop-up studios, cloud innovation labs, gaming garages, AR, VR studios, market space, innovation, venture development centers, robo rides, AI parks, and so on. These are the new labs that the universities will have to come up with, technical institutions will have to come up with if you really want to produce labor 4.0 for industry 4.0. Now, let's see. Now, this is a view of a code lab where you teach Python, or you teach the hot skills which are so essential for the industry today. You have pop-up studios where you create content, and you do the you build the teaching learning process into something that is realistic for an asynchronous learning environment. This is a maker space which will have, in fact, many of the universities and institutions have this already in place. They allow students to come up with ideas, or faculty would probably provide theme-based ideas, and the students have a free hand. They can use all kinds of facilities are available within this maker space. You want a 3D printing facility, or you want some research facilities, some CNCs, some all kinds of manufacturing tools. Everything is available. The software tools are available. They're connected to the code labs and so on. They also get external help from similar makerspace labs elsewhere in the world. In fact, MIT pioneered the Fab Lab, and these are the future things which university must adopt if they have to remain in business. So a future probably would have a campus on a cloud, and everything that runs a campus will also function on the cloud. So this is a gaming. Gaming is going to be a billions of dollars industry in future, and therefore it's a very good idea to set up a gaming garage within a university and allow people to experiment and figure out for them new gaming algorithms which will come back into the real life working that will be required for future. So what is the the end that we have? So we are moving towards a labor 4.0, and therefore education must support that. In fact, future of education is you meaning the students of today, and the future, and the faculty who handhold the students. So knowledge is acquired, and knowledge acquired under compulsion obtains no hold on the mind. Now, this is the future. The spirit of this statement actually is the future. What it means is, don't put any pressure on what to learn, how to learn, when to learn, and things like that. Knowledge must have no compulsion on the mind. And Darwinianism actually has a future for us, a future belief. Darwin says survival of the fittest, but Keynesianism adds something more to it. Those who are not fit must be trained and brought to the level of those who are fit. So that's what it is. Thank you for the attention, and it's been my privilege to be here, and I hope people have something that they can take from this presentation. Thank you so much.
Thank you so much, sir, for your enlightening keynote address on education and future challenges. We truly did not imagine some of the future challenges we need to face after COVID-19 pandemic. It was very informative, mind-blowing, and I am sure this will compel to rethink about the future education system and the challenges. Everyone attending your keynote speech. Thank you, sir. Sir, I know in spite of your busy schedule, you spared your valuable time by accepting our invitation to be the keynote speaker for today's session. But I see many participants have questions. So,
Yeah.
if you allow, can we have 2, 3 questions, sir?
Yeah, sure, sure.
Thank you, sir. So, my first question to you, sir, how do you feel about the competency of students having online education compared to the classroom laboratory learning in colleges? Will it have an impact on placements?
No, first of all, online learning requires a great amount of motivation on the part of the student. It's a paradigm shift. Uh, COVID has only made us move towards a learning experience that was there for some time, but it has made it more mandatory in these times. So, as far as the classroom experience versus online learning experience is concerned, it all depends on the kind of content that you are looking at and the kind of interaction that it provides for you uh, from a learning perspective. Within the personalized learning that I was talking about is possible in many of the known platforms, and therefore uh, if people are onto it, like for example, the edX content or the Coursera content or the Udemy content, these are uh, content-wise very, very rich, and they allow you some amount of personalized learning. So therefore, you may not really miss much in that sense by not going to a classroom. Uh, Though, like I said, the online content, the online education per se, does not have a, a typical uh, quality assurance process today. So therefore, you might find a lot of content which may not fit the bill. And if you are into it, then the experience can be a little difficult, doubtful. Thank you.
Thank you, sir. Uh, one another question from other participant: how you would like to guide the students from rural areas
Yeah,
for the use
yeah,
of e-learning methods?
yeah. Yeah, there is certainly a real problem when we talk about rural places and so on. The internet connectivity may be bad. Most of them may not have smartphones in that sense and so on, and therefore they may not be able to connect onto the content like urban student does. So in those kind of situations, I believe the government has a certain role to play. There can be tablets which are explicitly designed to, get the content and beam it. Those kind of things are possible for a very small price, like 5,000 rupees or whatever. So that's one place. The the cable network can certainly be used for this purpose, and because a cable probably has reached even the remotest of villages. And if some arrangement can be made for 3, 4 hours of time, which can be used on that network, it's very, very possible. Then there are also dedicated channels which the government has announced, which is extremely good for education, for beaming education content. And that's also going to help this process. But all in all, one would really require to take extra effort to reach the rural places in these times of difficulties.
Thank you very much, sir. It was really a good solution given by you. Now, can I take one more question, sir?
Yeah, sure.
So, in Labor 4.0, will there not be threat of more unemployment in India or many other countries in the world?
Whenever there is a technology change that has happened throughout the world, initially there have been some amount of labor turnover kind of problems. And it's quite possible that when you have a great amount of automation coming in, then at that point of time, there could be some questions on employment, retrenchments, and things like that. But having said that, there are people would require new skills. So there is a certain amount of reskilling that is required. There's a certain amount of upskilling that is required. People must be willing to change. Whether we change or not, the technology is making us change. So it's not as if we are driving the system today. Unfortunately, the technology seems to be driving the people around. So it's much better to move with the times and the requirements of the times. And the requirements of the times says that you need to be mobile, you need to be agile, you need to understand the dynamics of the change that is happening around you. And therefore, reskilling and upskilling is something that's extremely important. As far as the educational institutions are concerned, the same applies again. I don't think there will be real retrenchment of teachers and so on because online education is happening. It's not like that. Teacher will never become redundant. And I believe but at the same time, I also believe that teachers will have to change themselves by adapting to the new requirements that are happening, most of them in a virtual world. Thank you.
Thank you very much, sir. So, last question from Dr. Vilas Shinde. What will be the impact of learning, online learning, teaching learning experiment on social life?
See, social lives, obviously there is anything that you do will have an effect on multiple stakeholders. The society also will have a certain amount of participation in online learning. For example, the when a child learns online, the parents will have to have a much more active role in that, and will have to handhold the children and do what a teacher probably does in a classroom much more effectively in an online environment. So from those kind of aspects, the society will have to also change in terms of the learning experiences that the children would have. Plus the amount of the kind of networking that is happening today will have to change substantially in terms of understanding the children's requirements vis-a-vis the learning platforms that are available and so on. So in some way, the classroom learning will shift into the drawing rooms of people, and that's where the societal influences will be affected.
Thank you very much, sir. It was an excellent session, and it was really unique. Thank you very much.
Thank you, sir. Thank you.
Thank you so much. Thank you, everyone. Thank you.
Now, I request my colleague, Professor Satyanarayan Sadala, to propose vote of thanks. Over to you, Professor Sadala.
Thank you, Professor Katne, sir.
Good morning, you all. It is indeed a privilege to have respected eminent speaker, Honorable Dr. S.S. Mantha, in this online faculty development program. His insightful keynote talk on evolution of competencies for new era or education 4.0 was full of wisdom and information. He shared with the participants the tips to make optimal use of online education 4.0 tools. I feel all the participants who attended this session will be able to extract best results by applying these tips in their teaching and learning more effectively. I, on behalf of the Institute, thank you very much, sir, for having spared your precious time for all of us. I also thank all participants for spending their valuable time for this session. Thank you all. Over to Professor Kachne, sir.
Thank you, Professor Sadala. Now there is lunch break. But before we conclude this session, I have some announcement for today's afternoon session. The afternoon session will be engaged at 1 p.m. by another eminent speaker, Mr. Subho Ghoshal. He is ex-CEO TVS Infrastructure, who is alumni of IIT Kanpur. Now, the topic on the topic, creating a content to develop a future vision and mission post pandemic. So please join at 1 p.m. Thank you, everyone. I
Thank
request
you.
the host